All right, welcome ladies and gentlemen. This is video number 4 in our moles, reactions, and Stoich series. On this video, I'm going to be talking about calculations that we can do with hydrates. We talked about what a hydrate is in class. We talked about naming them, and now this is going to be what sorts of things can we calculate with them. So specifically looking at gram formula mass and different ways of getting percent composition of hydrates, both from the formula and from mass data. So first up is molar mass of the hydrate. So this is the gram formula mass of the hydrate. And the key to calculating gram formula mass of a hydrate is, first of all, recognizing that's not really any different from calculating the gram formula mass of any other compound. It's just that you have to take the waters into account. The waters are going to add mass. We call a salt the non-water part of a hydrate, so like everything except the waters would be the salt part of the hydrate. And the absolute crucial thing in remembering when talking about molar mass of a hydrate is to think about the dot that's in the formula, right? This is the example that we're going to do, the gram formula mass of the magnesium sulfate heptahydrate. This dot right here, it doesn't mean multiply. I know it means multiply in math class, but this is not math class, this is science class. And the dot is saying it's a magnesium sulfate and 7 waters. And if you think about what and means mathematically, it means addition. So the dot means add. Don't multiply. So realistically, finding the gram formula mass of magnesium sulfate heptahydrate means that we just have a magnesium sulfate and 7 waters. So in finding the mass, we're just going to find the mass of all of those things. A magnesium, a sulfate, and 4 oxygens, and then 7 waters. So magnesium plus sulfur plus 4 oxygens. Again, oxygen is O, but it's not one differentiated from the 0. And 7 waters. So what's the mass of magnesium? Magnesium is 24.3 grams per mole. What's sulfur? 32.1 grams per mole. 4 oxygen, so 4 times 16, plus 7 waters. Well, what's the gram formula mass of water? Well, it's 2 hydrogens, so that's 2 times 1 plus 16 for the 1 oxygen gets me 18 grams per mole. So I'm going to do 7 times 18. And when I simply sum all of those together, I get the gram formula mass of the hydrate, which is 232.4 grams per mole. And there we go. There's gram formula mass of the hydrate. So again, the big point in this is that the dot means add, and the number out in front of the waters, that's an important number. You're going to have to multiply the mass of water by that number and then simply sum it to the other ones. Now, percent composition of hydrates. So a typical example of this would be to calculate the percent by mass of water in magnesium sulfate heptahydrate. Notice that I'm using the exact same hydrate that we already looked at, because the key to solving a problem like this is to, first of all, find the total gram formula mass of the compound with all of the waters included, because that is going to be your whole. Then find just the mass of just the waters, and that is going to be your part, and then simply divide part by whole, because percent composition is still part over whole times 100. And when we talk about hydrates, we're typically looking for the percent by mass of water. So the water is always going to be the part, and the entire thing is going to be the whole. So using this previous example, using this magnesium sulfate heptahydrate to show you how we do this, so we want the percent water in it, so we want part over whole times 100. If we're looking for the percent of water, in this particular problem, that means the 7 waters, that is our part. The whole thing is the magnesium sulfate heptahydrate, that's the whole, so like the whole compound, times 100. That's going to give us our percent water, right? Our part over our whole times 100. So what's the part going to be then? The part is going to be the 7 water. So we're doing the 7 times 18, again from the formula. So this is like the mass of the water in the compound. What's the whole? Well, we just worked out the whole in the previous problem, so I'm not going to go through the math again, but it's the 232.4 grams per mole. Then we multiply that by 100. That gets us 48.2% water. So again, part over whole in percent comp, it's no different with hydrates. It's just typically in hydrates we talk about the percent water, so the part is going to be the mass of the water that contributes to the overall gram formula mass, and the whole thing is going to be the gram formula mass of the entire compound. But we can also look at hydrate percent composition problems in terms of mass data, meaning what if I don't give you the formula for a hydrate? What if all I give you is information like this, right, where it says a hydrated salt has a mass of 5 grams. After strongly heating it for 60 minutes, the salt now has a mass of 3 grams. What is the percent water in the hydrated salt? There is no formula here for you to find gram formula mass from, but we can still work out the percent water. And the key is to understand that when we analyze a hydrate, we heat it, and when we heat it, the water gets removed. So we start with the entire hydrate, all of it with the water intact. You strongly heat it. The salt portion, the non-water portion of the hydrate, will not leave because it will have a much higher melting point than the water will. The water, however, will leave. And if you look at this problem here, it says a hydrated salt has a mass of 5 grams. So pulling out what we know. What do we know? We know that the whole thing, the hydrate mass, is 5 grams. And then it says we strongly heat it, okay, for a period of time, 60 minutes. And it says the salt, remember, that's the non-water part, now has a mass of 3 grams. So we know that the non-water portion has a mass of 3 grams. And says, what is the percent water in the hydrated salt? Well, percent is still going to be part over whole times 100, because it's always that. We do know one of these numbers right now. We know that the whole thing, right, because this is the whole thing, this is our whole. So we know that the number on the bottom is going to be 5 grams. We want the part, right, and water is the part that we're interested in. The hydrated salt is the whole. So thinking about how we're going to get the mass of the water, what happened in this problem? Well, we started with a mass of 5 grams, then we heated it, then the mass went to 3 grams. So why did the mass go down? And the answer is because the water evaporated. The water left. Okay, so the water left. We started at a mass of 5 grams, we heated it, then it went to 3 grams. So what is the mass of the water then? The mass of the water is going to be the missing mass. Because the water left. So we started at 5 grams, we heated it, then it became 3 grams. We lost 2 grams of mass due to the water evaporating. Which means that we know that the mass of the water must be the difference. The 5 grams that we started with minus the 3 grams that we end with gives us the 2 grams of the water that left. This then allows us to solve the problem. I'm going to erase that again, because we can now plug in this value for our part in our percent composition. So our percent water in the hydrate is going to be the 2 grams of the water that left, that evaporated, divided by the 5 grams that we started with, times 100, which gives us an overall percent of 40% water. And in class, we're going to be practicing with both of these types of problems for percent composition, and also practicing figuring out the gram formula mass of a hydrate.